Hey everyone, we're back for more calculus. This time we're doing our chapter 6 test, chapter 6 practice test. We're going to do questions 7, 8, and 9. So let's have at it over here. So for this first question, you can't do it without having some trigonometry knowledge. The two equations that kind of go together here are these ones here. 1 plus tangent squared equals secant squared. And we're going to use that to simplify our integrand. The mnemonic for remembering that is 1 tan secretary. All right, so 1 tan secretary, 1 plus tangent squared equals secant squared x. The other trig formula that kind of goes along with that is 1 plus cotangent squared x equals cosecant squared x. And the mnemonic for remembering that one is 1 cottage cheese. 1 cottage cheese isn't quite as memorable as 1 tan secretary, I guess. Or, I don't know, maybe it is if you really like cottage cheese. So, let's see how this gets put into action. If I want to integrate secant cubed theta tangent theta on top of 1 plus tangent squared theta d theta, I have no hope of doing this because this is a very complicated quotient, and of course there is no quotient rule in integral calculus. So there has to be a way to simplify this. And looking at that denominator, that's the 1 tan secretary part, or part of 1 tan secretary. So we'll just substitute the rest of the tan secretary in there. Tangent theta. So 1 plus tangent squared, that's equal to secant squared theta d theta. And I think I made that square look like a cube. D theta. So now we have an opportunity to cancel out two secants from the numerator. So that just leaves me with secant theta tangent theta d theta. So we're not quite out of the woods yet. We have to recognize secant theta tangent theta as a derivative of secant theta. So the derivative of secant theta, that's equal to secant theta tangent theta. So the antiderivative of secant theta tan theta is just secant theta plus constant. Remember, the antiderivative and the derivative work backwards from each other. And we'll get ourselves to question 8. Yeah, if the derivative of one function is, if the derivative of f is g, then the antiderivative of g is f. That's the way antiderivatives work. That's the way integrals work. Number 8 is kind of worded in a way that's going to confuse people. It says to use the fundamental theorem of calculus to evaluate this. Well, there are two parts of the fundamental theorem of calculus, and the one that applies here is if you take if capital F of x derivative is equal to little f of x, that means the antiderivative from a to b of little f of x dx, that's equal to big F at b minus big F at a. Okay, and that part of integral calculus is basically just how do you evaluate a definite integral analytically. And this is how we do it with antiderivatives. So the first thing we're going to have to figure out is what is the antiderivative of, and I'm going to rewrite this so that it is favorable to us, t to the 1/3 minus 2 dt. Okay, well, I'm going to use the power rule pretty slowly because I know this is the first time we've done it. So the power here is 1/3. So we're going to do a 1/3 plus 1 on the denominator, and we'll multiply t to the 1/3 plus 1. So that takes care of that first term. That second term, the derivative of a constant is a constant multiplied by the variable of integration. So it looks like the only thing we need to simplify here is this first term. 1/3 plus 1 is 4/3, and the reciprocal of 4/3 is 3/4. So this is 3/4 t to the 4/3 minus 2t, plus constant, of course. Now when I get to the definite integral, integrating from -1 to 1 of the cube root of t minus 2 dt, well, that constant doesn't really matter because we know it's going to subtract out of the final equation. So I'll just put the antiderivative here without the plus c. And I'm going to put a -1 to 1 over here, indicating that I'm going to take a difference of these two antiderivatives. Next step, you're going to substitute 3/4 of 1 to the 4/3 minus 2 times 1. Okay. So I've substituted 1 minus, now I'm going to substitute -1. 3/4 -1 to the 4/3 minus 2 times -1. So try to be deliberate about this with the substitutions. Don't try and do 2 and 3 steps in one line worth of work. That's only going to encourage you to make algebra mistakes. Gosh knows, I don't want you to make algebra mistakes. All right, what do we have here? The 1 to the 4/3 power is 1. So this is 3/4 minus 2. -1 to the 4/3 power is -1. So this is -3/4 plus 2. And let's see how this works. We've got, well, no, let's be very deliberate with our algebra. We're going to make that a plus sign. We're going to make that a plus sign. We're going to make that a minus sign. 3/4 plus 3/4, that's 6/4, which is 3/2. Minus 2 plus -2, that's minus 4. And believe it or not, that's a good enough answer for calculus most of the time. This is something which you can do on a 4-function calculator. So you can probably leave that, but just in case, let's do a little bit of arithmetic here. This is 3/2 minus 8/2. 3 minus 8 is -5. So this is -5/2. So that's our question 8. And we've got one more to go here. And this is that same idea that we talked about on the previous problem, number 7. This is a quotient, and there is no quotient rule. I'm not saying there's no quotient rule as in we're going to learn it in chapter 7. I'm saying there's no quotient rule at all. You will never learn a quotient rule for integrals. It doesn't exist. So once you know that there is a way to simplify this. And this is kind of like something you did in Calculus A. So we're going to take that numerator and we're going to factor that. That is, what is that? 5 plus x over multiplied by 1 plus x on top of 5 plus x dx. Isn't that nice? The 5 plus x's are going to cancel out. So that's going to be equal to the integral of 1 plus x dx. The antiderivative of 1 is 1 times x. The antiderivative of x, well, that's x to the first power. So it's 1 over 1 plus 1 multiplied by x to the 1 plus 1 power plus constant. We can simplify that. X plus 1/2 x squared plus constant. And that takes care of question number 9. So really, that phrase that I've used a few times in this video in particular, That's really going to help you it's going to stop you from making a lot of calculus mistakes that many rookies make. There is no quotient rule for integrals. Once you get that through your head, then you start looking for ways to simplify the integrand rather than trying to make up some crazy quotient rule. That's not going to work. So I hope that was enjoyable to you, and I'll see you next time for more calculus.